Bismillahirrahmanirrahim. Assalamu alaikum. In the today's lecture, we will be solving two examples. One example will be related to the analytical force analysis, and the second example will be related to the graphical force analysis. This is the first example. Uh, this example states determine the reaction forces and the driving torque for the 4-bar linkage in the figure shown. The input crank is operating at a constant angular velocity omega 2 equal to 48 radian per second counterclockwise direction, and the applied force acting at point C is Fc equal to 0.8 in the vertical direction kilonewton. The masses of link 3 and link 4 are also given, and the second moment of inertia of link 2, 3 and 4 are also given over here. So what we are required, as you can see in the figure, below the figure, the lengths of all the links they are given, like the lengths of all the sides they are mentioned over here. Similarly, you can have other angular data from the figure that we will use later on during once we are solving this problem. So the moment of inertia is also given to us, the masses are also given to us, okay, and only one external force, that is Fc, it is applied on link 4. The other links, they don't have the external forces, they have the reaction forces, but they don't have like the external force like Fc. It is only applied to link 4. So what we are required to find the reaction forces and also the driving torque. The torque is actually the driving torque, it will be applied, it is actually applied to link 2. So what we will do, as we discussed previously, so this is an analytical problem. So we will consider the forces. We will start from the known side. Over here the force Fc is applied, whose magnitude and direction is known to us. It is in the vertical direction and the magnitude is also given to us. And so we will start from link 4 and then we will go toward link 3 and then we will go toward link 2. Where in the link 2 we have to find the moment, the torque that is responsible to rotate link 2. Okay, so the first step is to come up to find the as already we have the distances in so using these distances, we will convert these distances, we will express them in the real and in the x in the y direction, because we have x and y Cartesian axis. So we will denote all the distances in I and in j direction. Okay, so this is how we are starting from this. The assumption is that there is no gravitational forces. We are not considering force mg, okay, for all the three links, link 2, 3 and 4, and also the friction effects are also neglected. So over here you can see all the distances like RaO2. Where is RaO2? This is RaO2. The length of link 2 is 60, so we can write it in this form, 60 millimeter at an angle of 115. And similarly also we can write it in this form, in form of I and j, where this 25.4 will comes when you write 60 cos of this angle, and this will come when you write 60 sine of 115. Okay, so we can write all the lengths in this system in this form. And now we can come to the the second part, that is actually to use the kinematical analysis and to find the acceleration. Like over here we can use the kinematical method that we previously have used, and we can calculate the value of alpha 3 and alpha 4. Similarly, we can find the value of acceleration ag3, and we can also calculate the value of acceleration ag4. So this is, we will not do we will not discuss the kinematic analysis, and we will not do it over here. Next, in order to find the the reaction forces, we will also find the, as already we have the masses, of link 2, 3 and 4, and now we also have the acceleration about the gravitational point. So now we can, and also the alpha, the angular acceleration. So now we can come to find the reaction forces and the reaction moment. The reaction forces, let's suppose for link 2 it is equal to m2 ag2, and we know that the acceleration for the link 2, we are not considering the about the gravitational point, we are not considering the inertial forces, and also we are not considering the inertial moment. Okay, so that's why the inertial force and the inertial moment for link 2 will be equal to 0. Okay, and because it is rotating at a constant angular velocity, so the angular acceleration will be equal to 0. So that's why the over here the m2 ag2, that is the reaction force, it will also be equal to 0. Okay, and similarly if omega 2 is equal is constant, so alpha 2 will be equal to 0. Okay, so that's why the inertial moment will also be equal to 0. This is the first thing. And for the link 3, we have the value of m3, that is 1.5, we have ag3, so we can calculate the reaction forces, the inertial force for link 3. Similarly, for link 4 we can also calculate the inertial force. Similarly, the inertial moments for link 3 and for link 4 we can calculate it in here. Okay, so if you remember, in the graphical method, whenever we are doing this force analysis, we are finding the forces, so we find the value of h, but we will not calculate the value of h in this case, because this is not the graphical method, this is the analytical method. In the next problem we will finding the value of h. Okay, the next step is to have the free body diagram for each one of these links, link 4, 3 and 2, and thus we can calculate the unknown values, the unknown reaction value, forces, and the moment that is applied to link 2. Okay, so the first is, let's take the moment for link 3. We can take the moment at point A. Okay, so at point A, so how many forces we take the moment at point A? Okay, so the first force is, that is the force, the reaction force is at x at the g3 point, so that will be m3 ag3. Okay, because it is creating a counterclockwise moment, so that's why it is minus m3 ag3 into this moment arm, that is r g3a, starting from here until here. Similarly, the moment, the reactive moment, that is ig3 alpha 3, that is also in counterclockwise direction, it is also the second moment. And the third moment will be the force that is applied from link 4 on link 3, that is F43 into RBA. RBA is from here to here. So there are three components in the summation of moments about point A. One is due to a reaction force, the other moment is the reactive moment, and the third one is due to the force that is applied from link 4 to link 3. Okay, now we will come to link 4, and link 4 we will take the moment about 0.04. so over here how many forces we have? The first force is FC into RC04. Okay, starting from C until 04, this is, it will be in the clockwise direction, so that's why it will be negative. Okay, and the second one will be this is, where is the other one is the other moment is due to the reactive force that is applied over here, that is m4 ag4. Okay, so m4 ag4 into rg4 o4, this is the distance from g4 until o4. Similarly, we also have the reactive moment. Okay, and we also have a moment due to the force that is exerted from link 3 to link 4, that is F34. So F34 into this moment arm, starting from B until O4. So we will take the summation of moments about 0.04 equal to 0. Okay, so the next thing is to to put the value of RG3A, that we already know where is this value. If we go back and we come here, so we can put all these values in that summation of moments, these two equations. So once we substitute the value of all these moment arms over here, so we will once we calculate, and so we will get these equations: summation of moment at point A equal to 0, summation of moment at O4 equal to 0. So we can rearrange this equation and we can solve them, because we have two equations and two unknown. So we can find f3 for x and f3 for y from here. Okay, and once we have these equations, now the only thing is to take the summation of forces at link 4 and the summation of forces at link 3 and summation of forces at link 2. So the summation of taking the summation of forces, it will give us the reaction forces, the unknown reaction forces. So once we take the reaction summation of forces at link 4, so it gives us the value of F14. When we take the summation of forces at link 3, so it gives us the value of F23. And once we take the summation of forces at link 2, so it will give us the value of F12. So this is how we find the unknown reaction forces. The next step is to calculate the moment that is applied to link 2. So for that one, what we will do, we will take the summation of moment at O2 equal to 0. Okay, so once you take the summation of moment at O2 equal to 0, okay, so we know that the inertial moment, it is equal to 0, because alpha 2 is equal to 0. So this thing is equal to 0, and we can move this F3 to the F3 to force will be acted upon here, and it is exactly equal to the value of F23 that already we have calculated in the previous step. Okay, so if 23 and 32 will be equal to one another, okay, that already we have calculated over here. If we go back to the previous step, so this is F23. Okay, so the value of F32 and F23 will be equal to one another. Okay, so from here we can find the unknown torque that is applied to link 2. Okay, so how did we solve this question? Okay, we were required to find the reactive um, the reaction forces and the moment that was the torque that was applied to link 2. So for that we start from this side, because over here we have the known force Fc. So we start from link 4, okay, and then we move to link 3, and then we move to link 2 in order to find all the reaction forces in this problem, and also to calculate the torque that was applied to link 2. Okay. The next problem is actually the problem 2. The example 2 is related to the graphical method. You can see the 4-bar mechanism, and in this 4-bar mechanism, this is the given data to us. Okay, we have like 1, 2 and 3, and what we are here, it is given that for link 1, I is actually for link. So the reactive forces for link 1 is equal to 0, and the reactive moment is also equal to 0. So we are not considering the effect of G, or we can see the effect of mass over here. Okay, so we are not considering MA or the MA force or alpha into moment arm, the moment. We are not considering the force and moment for link 1 and also for link 2. It is only considered for link 3. So for the link 3, the moment, the reactive moment force is considered, and it is applied at an angle of 125. Okay, 128, sorry. And also the moment, the magnitude of the moment is also given. It is positive because it is counterclockwise. So in this case, what is required to find the torque T that is applied on link 1. So this is similar to the one of the problem that we have solved in the previous lectures. If you remember, we discussed that we will start, as over here the reactive force is known, so we will start from here. What we will do is, the reactive force is given to us, so and also the reactive moment is given to us. So we have to find the value of offset distance. That offset distance will be actually the distance over there, if when we applied the reactive force, so it will cancel the effect of the reactive moment. Okay, so we need to find the value of H3 such that the force into H3 should be equal to the reactive moment. So from there, from that equation, we can calculate H3. Once we know the H3, so we will apply the reactive force F3 at that line of action. Okay, so F3 direction is known and magnitude is known, and for link 3, the force that is applied from link 2 to link 3, sorry, so the direction of that force is known. So once, as we discussed previously, if for one of the force the direction is known, the line of action is known, and from the second force, if it is completely known, then we can find the concurrency point. Once we know the concurrency point, the force exerted by the ground, the reactive force from ground to link 3, we will just connect this point with the concurrency point that we get. Okay, so once this force polygon is solved and we have the force F23 from here, so the same force will be like if 3-2 will be applied on we will apply it on link 2, and it will have the same magnitude, that will be F21. So F21 will be the same magnitude. So the only thing in this problem is to focus our concentration on the force polygon and to learn how to solve the force polygon. So we are starting from the input data. This is the reactive forces that is given to us, that is applied at 128 degree. The direction is in upward direction because it is positive. So you can see it is in the applied at 128 degree in the upward direction. Its magnitude and direction both is given, and over here we can have a scale because it is 3000 and 30,000 Newton millinewton. So we can consider like we can convert it into Newton by dividing it by 1000. Okay, so and then we can have a scale in centimeter or maybe in inches, but this is in Newton, so we should have a scale in centimeter. So once we scale it down to the scale it up to the centimeter, then we can put the length of this force that is applied on link 3. Okay, but another also we are given that inertial moment is applied on this system. In order to cancel the effect of this inertial moment, this force has to be applied at a certain offset distance. So this offset distance will be calculated when we divide the moment by the reactive moment by the reactive force. So over here we can have this distance, and then we can use the same scale. Okay, using the same scale we can the scale we can have the scale, and then we can move the force over there. Okay, so this is how from here then we will draw the force. Okay, so we will draw the force, and also we know the line the direction of F32. It should be, this is the force exerted F23 that is exerted from link 2 until link 3. Okay, so this force should be aligned along the length, because this is a two force member, we are not considering V2 over here. So this will be the concurrency point, because the force from here and the force from here, they are intersecting at this point. So this is basically concurrency point. Once we have the concurrency point, the next is the direction of the force that is exerted by the ground link to the link 3. It should be starting from here, and it should also pass from the concurrency point. Okay, so this is how, this is the concurrency point CP. Okay, now we will connect O3 with CP. Okay, so it will give the direction of FO3. Okay, now let's move the, so this is actually the force polygon. Okay, we can use this scale over here. Okay, and now we will move this force polygon over here. This direction and distance is known to us. For this force we know the direction, for this force we know the direction, and once they intersect at a point, so we can measure this one in the centimeters, and we can convert it into Newton because already we have the scale. So once you know the F32 from here, So this if 3 2 have the same magnitude just like if 2 3. uh, we know the if 2 3, so if 3 2 and if 2 3, both of them will be having the same magnitude. Okay, so next, the next step is to, so actually this is the fourth polygon that comes from the link 3. Once we know the magnitude of all of the fourth component, if 3 2 is 1.75, this is 2.9, and this is 3 centimeter. Okay, so now we will come, so this was our link 3, so these are the fourth component over here. Okay, so if 3 2 and if 2 3, they will be having the same direction. So this is the same 17.5, and the 17.5, it will also come to the link 1. Okay, so now we will come over here. In order to find the moment over here, we have to take the moment, summation of moment over here. Okay, so the same force F21, it will be applied, the force exerted from link 2 to link 1, it is 17.5, and there should be a couple. In order to cancel the effect of the torque or the moment, the torque that is applied over here, we should have a couple, and the now we will take the summation of moment over here in order to find the value of the input torque. Okay, and for that we need the moment arm. Starting from here, the distance between these two couples should be measured. Okay, and should be we should use the proper scale. Okay, in order to find the value of t, okay, on the input link 1, so we will take the summation of moments. Okay, and we know that the inertial moment is not taken for link 1 and 2, so the inertial moment should be equal to 0, and plus t plus this force F21 into the distance between F21 and F01. Okay, we will measure this distance, that is d. Okay, so this d will be calculated from the graph, and then it will be, we will use the proper scale to calculate it into the real value, that is 26 millimeter. Then we will take the summation of moment about 0.01, that will give us the value of t. Okay, so this is how we solve this problem. We actually we started from the input link, we started from link 3, because with link 3 we know the direction, and we also know the magnitude of the inertial force that was exerted over here. So we started from link 3, we solved the fourth polygon. Once we have the value of if 2 3, okay, from this fourth polygon, so the force F32 will be having the force F32 on this 2 force member on link 2. It has the same magnitude as this force, and the same force will then, this 17.5, this is the same force, will also be exerted over here. So once we know the value of this force over here, then we can easily find the value of torque that should be applied to link 1. So this is how we move from the output link, and we come to the input link, and we were able to find the inertial forces, and the reaction forces, and also the input torque. Okay, so in the next lecture we will further discuss 2 more examples. Okay, related to, these are the practice problems for you people. So if you have any problem in these 2 problems, so try to solve these 2 problems by your own, and if you have any problem, so we will discuss it during the lecture. Okay, so